Hello and welcome CogX to today's Lunch and Learn with Peltarion. This was pre-recorded to be honest, so I'm not exactly sure what time it is where you are, but hopefully you're enjoying lunch or maybe even a fika like we do in Sweden for today's session where we're going to talk about image classification. Or more simply put, how do we make a machine be able to see what we see and comprehend what we see with our own eyes daily? The first thing I'm going to do in today's session is just give you a quick introduction on AI methodology, because I know there's probably various different skill sets and skill levels here on today's tuning in. So we'll cover that, but then we'll also give a quick gentle introduction, but hopefully a very effective introduction on what the model that we'll be using today and what it actually does. Then I will actually show you in the Peltarion platform how to build the model. And lastly, but most importantly, also show you how you can then take that model and insert it into applications that you might be building now or maybe dreaming about building in the future. So let's get started. Great. So the first thing I want to talk to you about is AI methodology, because a lot of people want to use AI in maybe their projects, applications, or businesses that they're running, but don't know necessarily where to start or how to actually kind of properly build a model or what the steps that needs to be taken. So the first thing we always want to start with is a business problem itself. So a clearly defined use case is obviously the best place to start for solving any problem, but specifically with AI, it's really good to understand what you're trying to achieve and accomplish, whether that could be automating a process that's currently bogging down a system, or classifying images or text, where you can then use that classification to make another system more efficient or people more efficient within your company. So understanding where you're starting from and the goal is the best thing to start with when working with AI. But the next and crucial thing is also having a data understanding. Because I like to say that a model might be the engine, but data is actually the oil or gasoline that you need to run it. So once you have a clearly defined business problem, you can go out and hopefully you're collecting data that is clearly aligned with that business problem. But if not, then that's a good place to start to understand and how to find ways to now incorporate AI and data collection within that process. Once you do that, that's when the fun begins, when you now can start building a model and understand which model that you choose based on the sort of problem type that you're trying to solve. Again, classification or a regression or even some other similarity type things is quite different models and architectures that you would be using. So also knowing which one's the best and most appropriate is another crucial step to model building. And then after, which I personally love, is actually the deployment. How to get the model out there and understand what is going on, how the model performs, because it doesn't actually have to end with the deployment. It's actually a completely learning loop where you can then collect more new data that might be relevant to the problem and the use case that you're developing on. So then you can actually continue to improve the model over time and continue to solve the business problem that you're doing even better and even more efficiently. So there's many different solutions that are out there in regards to AI and its approach. Like I said, there's kind of three maybe key areas, whether it's working with images, so classifying them, finding similar images, or text, where you can do the same thing, or even audio files that you can detect different nuances in sound to understand what maybe has changed in a factory, for example. So today we'll really talk about image classification, but just to give you an understanding and also some inspiration on how AI can solve some of your problems, here's just a quick synopsis there. But what is image classification? And I like this, love the quick go-to explanation of all this all the time, which is it's how the brain works, of course. And you know, if you're a brain surgeon and you know how the brain works or you have studied that, then yeah, you know, that's a great explanation. But it's really hard to understand that concept if you don't have any understanding of how our actual brains interpret images. So I won't give you and leave you with that simple example, but give you a little bit more in depth of how image classification is handled. But what are we talking about here? Well, I always bring up the classic Silicon Valley example from that episode where one of the entrepreneurs or startup founders built a hot dog no hot dog app, which is this, as you can see here, identifies whether in the image it's a hot dog or it's not a hot dog. and then you can share it. But that's exactly what it is. It's, again, teaching a machine to understand and see what we see, and then provide some sort of classification, whether that be a label on what is actually being shown there, and then you can take that information and use that for any other business case and problem that you're trying to solve. In this case, we're really just saying hot dog, no hot dog, which, I don't know, maybe that's a problem for many people. But the nice thing with classification with images is that we can actually do not only single label classification, so kind of the binary or looking at cancer cells where you can see whether it's benign or malignant as far as the signs on the skin, but you can also do multi-label. So if you take a image of a church here, you can actually also see now that what the model can see, which is that this is water and church. And it all starts with the data that we feed the model. So if we have a data set that has multiple labels, then the model can learn from multiple labels. If the model only has the data set has only 2 labels, then it will learn those 2 labels and understand what those images are. So again, it's really critical that you build a great data set that's attuned to the problem that you're trying to solve. But how does it actually work? Is it magic? No, it's just math. So maybe this is boring for some people, but machines, when they see images, they only see numbers. And we have 2 big things that we look at when we're actually looking at images for machine learning and AI work. And that is using I think is kind of the power horse of all image classification or image work is a convolutional neural network, or CNN for short, and not the news network in the US, unfortunately. So there's 2 main concepts I'll talk to you about to allow you to get the understanding of how neural networks work with images. The first is the actual convolution part. So like I said, it's the actual way that the image, not only of the machine actually takes the image and converts those into numbers, but then understands what's in the numbers. So it actually takes what we call a kernel or a filter and goes through the image. And this could be, let's say this is a 3x3 square that goes through the image and it understands exactly the concepts or does calculations on what's in those images 3x3 each time. And he does this multiple times. So first time it could be looking at just edges. Next time it could look at different textures. And then the third time, in another layer, it could actually pick up the actual objects. So like our eye works, right? I mean, it just picks up, we slowly interpret and we can see certain things, and then we kind of sharpen our understanding of what's in the image. And then we know what a cat looks like or a hot dog looks like. And we don't have to see all of the hot dogs in the world to understand what is a hot dog and what's not a hot dog. The next thing, our next major concept is max pooling. So after doing the filtering and doing calculations based on that, vector math is what's at play here, then we also can pool those kernels into even smaller sections. And I'm talking about max pooling here, where it's actually taking the max of the sort of weight math or the math that is being done. But we can also do average pooling, where it takes the average of that math that's being done on each of these pixels. And again, that then allows us to compute and train faster on these networks, which again, it's a great idea because neural networks can take a lot of time to train depending on how complex you're doing. So any sort of way we can gain efficiency is great. So this is a quick synopsis of how that looks. Again, we're taking the input, which is any image that we have there. And then we're also then doing convolutions on that. So again, taking the filter and kind of scanning the image in this case, a 2x2 square. And then we're going to take that and even condense it further into the pooling. So now it's, you can see in this example, 8 instead of 0, 6, 4, and 8. And then we'll take that and we'll go through dense layers. And dense layers is an idea where once the model is learning, it continues to change sort of the weights or the way it sort of understands the world. And the dense layers is where the really magic happens between computing and understanding what's in the images. And then it gives us a label. So in this case, we're trying to figure out what's in this image. And then it will have the target, which is the label of what the machine or the model thinks it is. So let's actually build a model, because that's where the fun really is. So in today's session, we're actually going to build an application that where I will be able to, or you are able to, upload a material, whether that be, let's say, wood, stone, or plastic, of any image that you find on the internet. And the model behind this application will actually be able to identify what's in that image and give you a label of what it believes it is. And you can use this for all kinds of things. Let's say if you want to sell these materials, you can imagine someone going through a warehouse and just taking snapshots through their factory, and then finding out, okay, great, I have stone, wood, and water here in my factory, and I would like to sell that. So it allows automation where you don't necessarily need to go through everything to understand how an image is or what the image is in there, and saves a lot of time and energy. So the actual data set, like I said, that we'll be using, which is, again, one of the most important parts of building an AI model, as a data set that takes Flickr, which is used to be a very popular image sharing before the world of Instagrams and Facebooks. And we actually already have about 100 images for 10 classes. So we have about 1,000 images here where we can see, and it's already pre-labeled, of what's glass, what's water, what's leather. And the model will take this, look at all those images first in the training process, and then it will understand, okay, what makes leather leather, or what makes water water. Then we'll give it another set of data to validate that, where it hasn't actually seen any of that in the training process, and we'll look at the performance of there and make improvements on it before we do the final test, which is a test set where the model has not seen anything, and then we're really trying to validate the results of the model. Great, let's get into the platform. So here we have the Peltarion platform, our no-code AI solution to building models with AI. So you don't have to be a data scientist or machine learning engineer to harness the power of AI and put that within applications that you're developing. So first thing we'll look at is actually the data set that we'll work with. So like I mentioned, this is a Flickr data set where we have a set of images, which you can see here visually, and the label. So we have various images of wood in different materials, layouts, and sizes there, and then the labels of all of those 10 classes that I mentioned earlier. The next thing we'll look at is actually the modeling view. So what the model looks like. And you can see, as we spoke about earlier, the convolutional layer, as also the max pooling. So the convolution doing the filtering, and the max pooling filtering it further down for improved performance. And then we also make the target, which is the final label of that image, or what the model will actually be predicting. So it's going to predict what it thinks the image is, or what class the image is within that, what it's seeing and what it's been training on. Then we have an evaluation view. So you can see here I've done multiple experiments on this data set. And I always like to say, I like that we call them experiments, because the best way to do AI is to do multiple experiments. You're never going to get this down first try on the model, always. So it's best to then go ahead and do multiple experiments to get better performance and understand and tweak settings to see which ones work best. But what I like to do, especially on classification problems, is go to this prediction inspection. Because you can actually then see what the model has predicted and what the actual label is. So you can see here that this was actually a wood block, but the model actually predicted glass and felt okay that this was the right prediction. And you can kind of see, maybe since the reflection on the bottom was there on the wood, and glass has that same type of reflection, maybe it was picking up those areas. But it's super nice because you can kind of, one, give the model some slack on complex images, but then also look at in different classes where the model has made poor predictions, and that means maybe you need to get more images on that data, on that particular class, and add that to the data set. So as the model learns, you can learn it as well. Next thing, and what I like the most, and the most important for me, is the deployment side. Well, now after you built the model and you're happy with the results, you actually want to use that in an application. So what we do here in the deployment side is actually establish a API endpoint where then you can make a request to that API, making, in this case, an image, and getting a response back, which is the actual label of the model. So you can do this quickly by doing a test deployment, which makes a page like this, where I can upload an image and get the result. But what's also fun is that we've also built integrations within many popular workflow tools like Zapier, or common office tools like Sheets and Excel, and even app building tools like Bubble. So I went ahead and made a very simple Bubble application like this, which is a no-code solution on top of our no-code AI model that we just built, where I can now upload an image of the materials and get a prediction of the label of what the model thinks it is. And also, you can pretend that this is going to also give you a price to where exactly the materials are. So again, you can sort of imagine someone going in through their materials in the warehouse, taking snapshots, and getting a price for what they can sell those materials on. So let's test how the model performs by uploading a material. So now we can see some wood here, or some timber, all stacked up, and that seems kind of tough to maybe call this wood, but we'll see what the model predicts and labels from this wood that we have. And the idea is that this is not something that's been in the data set, but a new image that it hasn't seen. And you can see the model has predicted correctly wood. So there we have it. Sort of end-to-end AI project where I've taken a data set, I've built a model, so a convolutional neural network, I've evaluated the results, and I've done multiple experiments to see which one works best, and then I've deployed that with an API and connected that to an application. So now I'll let real life me answer any questions you might have about AI, image classification, or the Peltarion platform. Thanks.